So today we're going to take some notes in our daily notes packet. So this should be with you again. Remember, we're saving it in our binders. We're bringing it to class every day. And we're going to fast forward in here to the section that we didn't get to cover the other day. So if you will turn with me now to lesson 1.2. Comes after our M over N discussion for rational numbers. If you notice, slide 1 we talked about the other day, and we talked about how that fraction bar means to divide, and we were able to find what we called terminating decimals. And we also worked on slide 2. We found some terminating decimals here and also on slide 3. Well, today we need to move on and look at another form of rational numbers. Rational numbers sometimes take the form of repeating decimals. So you should be here on slide 4. If you notice, this division really came from the fraction down below. This really came from 1/3, which really means 1 divided by 3. So they've already written it out for us. And they're also helping you out here because they say, well, 3 does not go into 1, and they're also bringing up their decimal place for you, and they record that with a 0. So they treat it like a 2-digit number now. We say to ourselves, how many times does 3 go into 10? And the answer would be 3. So that 3 goes up top, and we say 3 times 3, of course, is 9. We go ahead and subtract. And with a little regroup maybe, or counting up or counting down, you'll get 1 left over. Well, because we have something left, this hasn't terminated yet, so we need to put another place value in. So we're going to show a 0 in the hundredths place. We're going to bring that number down so we can treat this like another 10, and we say again, well, let's divide. What times 3 gets me close to 10 without going over? Or 10 divided by 3 is still 3. So that 3 goes up top in the hundredths place. And we multiply 3 times 3 to get 9. Let's go ahead and subtract, and you'll notice you have 1 left again. Well, there's still something down here, so we're not done yet. We need to go another place value. So if you'll show another 0 in the tenths, hundredths, thousandths place, we're ready to bring that digit down and treat this again like another 10. Well, 10 divided by 3 seems to be kind of happening again, so we'll get an answer of 3 here. And our quotient, 3 times 3 is actually 9, and we'll subtract again. Oh, this thing still hasn't ended, so I guess we're carrying on. So we're into the tenths, hundredths, thousandths, 10,000ths place. We need another place value to show, so we'll bring the 0 down and treat this like, again, 10. A group of 10 divided by 3 is, 3. So 3 times 3 is 9. We will go ahead and subtract, and I'm kind of noticing something is carrying on here, but this is interesting. We'll continue this idea of I still have something left over, so I'll continue in decimal land, a really fun place. Let's go another place value and bring down that 0. So now I have 10 divided by 3. Well, it seems to go in there 3 times. We'll show a 3 up top. And 3 times 3 still happens to be 9. Let's go ahead and subtract. It seems like if I continue doing this, it's going to go on and on and on forever. So what they're asking me to do is show that over here, that I'm going to continue to get 3s indefinitely. So to show that it's never ending and to be accurate and precise without rounding, I can show this ... to be continued. There's another way that we would shortcut this, and we would show with some math notation, also known as bar notation. We could write this as 0 and 3/10 repeating. We would also say that this has a period of 1, meaning there's only 1 digit repeating underneath that bar notation in the tenths place. So you only need to show as many times as represented here in the period as the numbers that need to repeat. So we only have 1 digit repeating. It's that 3, and we show its bar notation right above it. All right, down below, they give us a few more to try. And again, they're telling me that I can use some long division on these. So we're going to use long division for the first couple, and then maybe a calculator to try another. Let's see how this works. This really means 1 divided by 11. So let's go ahead and take that 1, make it your dividend, and it looks like we're going to have to go to decimal land, a really fun place. So I'll just carry out this decimal place value to, I don't know, maybe 3 or 4 zeros. See how it goes. This 11 becomes your divisor, and we are ready to bring up our decimal into our quotient and divide. Does 11 go into 1? The answer is no, so I'll put a placeholder here. So then I can say, does 11 go into 10? And unfortunately the answer is no. I can put a placeholder here. But 11 does go into 100. It goes in there, you guessed it, 9 times. 9 times 11 is actually 99. Go ahead and subtract, and whether you're regrouping or just counting down or counting up from that 99 to 100, you'll find 1 left over. We are ready to go again. This 1 is smaller than my divisor, so I know things are going well. I can bring down the next placeholder or place value. Does 10 divide by 11? The answer is no. So please be cautious. You have to represent this 0 up top, showing that we did try. We did say that we were going to divide 10 by 11, but unfortunately, we didn't have enough to make a group. So now we're ready to move on to the next place value. If I bring down another 0, this represents 100, and I could say 11 does go into 100. I think it goes in, oh yep, 9 times. Because 9 times 11 is still 99. Let's go ahead and do some subtraction here. If you do a regroup, that's great. If you count up from 99, it'll work. If you count down from 100, it would also work. You'll find 1 left over. Unfortunately, we can't stop. There's still something remaining here. So we're going to go another place value or 2, see what happens. I now have 10 divided by 11, and in fact, well, that won't work. So I'm going to have to make sure I save a spot up top showing I did try that division and go 1 more place value. I now have 100 divided by 11, and it happens to go in there, you guessed it, 9 times. And let's go ahead and see what happens with our subtraction. I'm starting to notice a pattern, and perhaps you already did. That's a good thing, meaning this is going to continue forever and always. It will never stop. To be continued. Well, there's a way that we would record this. We could show 1/11 with bar notation. So in decimal form, we would write it represents 0 and 9/100. And the piece that keeps repeating is not just the 9 in the hundreds place, it's the 0 and the 9. So we show a period of 2, meaning the bar notation covers both digits, covers the 0 and the 9 in the decimal. That's, again, bar notation. It shows repetition. All right, we're ready to go again. Part B. Which number becomes your dividend and jumps in? The top number, always. The numerator becomes your dividend. We're probably going to decimal land, so I'll just show that a few place values, so hopefully we're ready. And the divisor becomes your denominator. Next, I can say, does 12 go into 1? And unfortunately, the answer is no. Does 12 go into 13? The answer is yes, 1 time. Let's go ahead and subtract, and you're left with 1. If you bring down the next place value, we have 10 divided by 12. Will that work? No, not enough, so we show that we tried by putting a placeholder up top. We're ready to go to the next place value and treat this like 100. 100 does divide by 12. How close can we get? Let's see. 8 times 12 is 96. 9 times 12 is too much. So I guess we're going to go 8 times 12. 96. The 8 goes in your quotient. The 96 is for from our multiplication. We're going to subtract. And with a little regrouping, you'll find that there's 4 left over. We're ready to go. Bring down the next placeholder. Does 12 go into 40? It absolutely does. It goes in there, let me think. 12, 24, 36. Sounds like 3 times. So 3 times 12 is 36. And we subtract again, and we have 4 left over. Good thing I took the zeros out here a ways because we need to keep on going. There's still something left down below. Now I have 40 divided by 12. How many times does 12 go into 40? Well, again, 12, 24, 36. 48 would be too much, so we'll stop at 3 times. That 3 really should be right above my last 0. I can see I'm a little bit out of alignment here. Check yours, make sure you're being careful. 3 times 12 is still 36. And when you subtract, you are left with 4. Things are looking pretty good, but I notice starting to see a bit of a pattern, and I'm still left with 4 at the bottom. So we're going to go 1 more place value. 40 divided by 12 is, you guessed it, still 3. 3 times 12 is 36. You have proof enough for me. Something is repeating. Okay, the general rule is we need to look for 3 times in the repeat to make sure that we're preventing an error. So we usually check 3 times, and I happen to see some repetition here. I also noticed something really critical that we left out, and you can't afford to miss, but somewhere along the way, maybe you did. So if you go back here, we're really doing decimal division, right? We're moving from a fraction to decimal form. So this decimal should move into your quotient, and it should belong after the 1 and before the 0. So if this is going to continue, ... to be continued, the least favorite thing that they do with your show, right? We need a way to show this a more concise way. So we would take this 13/12. We would say that it's equal to 1, and 83 thousandths. And I can really stop here in the thousandths place because that's where that digit starts to repeat. The 3 continues to repeat as a 3 and a 3 and a 3 again and again and again. This would go on for the rest of your life. But to save us that work, show the bar notation over 1 digit. This has a period repeating of 1. Here's the answer that they're looking for, and if we back up here, here's the answer they wanted from this one. We are going to try the same idea, but this time calculator style. So if you take a look, first of all, what does this mean? It means take 82 and divide by 333. So in your calculator, the first thing you put is your dividend, your numerator. So let's see if this even shows up for you. So in your calculator, I'm typing in 82. I'm pressing the division symbol, and I'm going to divide by the denominator, or the n if you're thinking of m over n, equals. I'm going to write out some of the digits I see here. So what I see happening is 0.246246, and this seemed to have stopped after 1, 2, 3, 4, 5, 6, 7, 8, 9, count the 0, 10 place values. Okay, this would continue indefinitely. This isn't done. If you notice, there's kind of showing you an indicator up here. There's probably an arrow in your calculator. Most calculators will show you in some way, shape, or form it's continuing. So we can show to be continued, ... This is really long and your hand is feeling really tired. So we're going to be more concise and we're going to be accurate. We're not going to do rounding. We're going to use bar notation to show repetition. Any rational number can be written in either 2 ways. A decimal that terminates, like we talked about last time I saw you, or a repeating decimal, which I see here. So let's talk about what we see repeating. Seems to go 246, 246, 246. That's the pattern you're seeing. So we can be more accurate and more concise by writing 0 and 246 thousandths. There are 3 digits that repeat, so we have to use our bar notation over those 3. And again, just to be thorough, that came from 82 333rds. This is the answer they're looking for. We found a repeating decimal. This actually is rational because I found repetition. I found a repeating decimal. That's one way that we check rational numbers. Part D, we get to try again. It says I can use a calculator, but first I need to know what that means. So it means 2 divided by 7. So in your calculator, the first thing you need to do, probably clear out from your last problem and try 2 divided by 7. What's it get us? Let's copy down what we see. 0.285714,286. This one's really interesting, and this happens quite a bit. Again, they can only show you 10 digits on this calculator. Some calculators will show you kind of an extended format, but this one's stopping at 10 digits, 10 place values. So we're looking for what repeats. I notice a 2 and a 2 happening here, and behind the 2 is an 8 and an 8. Then I notice a 5 and a 6, which actually doesn't look like repetition, but here's what you need to notice. What would usually come after the 5? A 7. So if you could picture that this was maybe a 5 and a 7 and a ... this 5 would have to do what to shortcut it or to round up. So that's where the 6 actually came from. So it might be more accurate to show this was rounded on your calculator. So what your calculator really should show you is this: 0.285714, to be continued. Well, that's going to really ruin your hand today. So we're going to find a more precise way and a more concise way, shorter way of writing things. So we're going to write 2 sevenths we know is equal to 0.285714. I can stop at that 4 because I can see right here that it's going to repeat again. This set of numbers is going to continue repeating. So this gets bar notation over not just 1 period, not just 2. It actually has 2, 4, 6 digits, a 6-digit period. Okay, and this actually goes to the tenths, hundredths, thousandths, 10,000ths, 100,000ths, while the millionth place. Okay, this is a final answer. Again, today what you're learning to do is test to see if a number is rational, and rational numbers. First of all, they can be written as m over n. This is awesome because if they can, Then secondly, you're going to be able to turn them into either a terminating decimal or a repeating decimal. We're going to give you time to practice this today with my guest teacher.